Hi there, Mr. Sutton here, bringing you the IM3 Honors 1-4 Extra Practice Number 2 solutions on inverse functions. To find the inverse function on this one, we're going to switch x and y and then solve for y. So I've got x equals -20 plus y over 5. And then to solve for y, I have to first get rid of this fraction by multiplying 5 by both sides. So we'll have 5x over there. And then we just have to add 20 to the other side. So I can write g inverse equals 5x plus 20. To find the inverse function for this one, we're going to switch x and y in the beginning. So we have x equals -3 plus 7/3 y. Next, we have to get y by itself. So let me start by adding 3 over to the left side. And then to get y by itself, I've got some options here. The fastest way would be to multiply both sides by the reciprocal of this, so 3 over 7. And we can write then g inverse equals 3/7 parentheses x plus 3. Or if you wanted to simplify it a little more, we could do 3x plus 9 all over 7, just distributing that 3 and then dividing everything by 7. To find the inverse for the h function, we have to switch x and y. So we've got x equals -3y minus 12 over 2. And at this point, we're going to try to get y by itself. So let me multiply both sides by 2 to get rid of this fraction. Next, I'm going to add 12 over here so I can isolate the -3y. And then finally, I'll divide both sides by -3. So we have h inverse equals 2x plus 12, all of that over -3. To get the inverse for this g function, I'll start by switching x and y. So we have x equals -2 over y minus 1, minus 3. Next, to get y by itself, let's start by adding 3 to both sides. And let's see here. I'd like to get this y out of the denominator. So let me take the reciprocal of both sides. So I'll write 1 over x plus 3 equals -y minus 1 over 2. Next, I want to get rid of the fraction on the right side, so I'll multiply both sides by, let's make it a -2, just so I can get rid of the negative at the same time. So then I'll have y minus 1 equaling -2 over x plus 3. And then finally, we just add 1 to the other side. So we have g inverse equals -2 over x plus 3, all of that plus 1. For this problem, I'm trying to find the inverse of the f function. I'll start by replacing x with y and y with x. So this is going to be an x equals 5th root of y plus 2. And then to get y by itself, which is our next big step, we have to take the 5th power on both sides. So we'll have x to the 5th equals y plus 2. As a final step, we're going to subtract 2 from both sides. So this is going to be f inverse equals x to the 5th minus 2. To find the inverse for the h function, let's begin by switching x and y. So we have x equals 3 over y minus 2. And then we'll isolate y. So we'll have, let's see here, x plus 2 equals 3 over y. We're adding 2 to get the fraction by itself. And then I don't really want y in the denominator, so I'm going to take the reciprocal of both sides of this equation. So I'll have y over 3 on the right side, and then I'll have 1 over x plus 2 on the left side. Now that I've got y in the numerator, I can get it by itself if I just multiply both sides by 3. So I can write h prime equals 3, or not h prime, h inverse equals 3 over x plus 2. For this problem, I need the inverse of h. I'll get that by first replacing x with y and y with x. So I have x equals y plus 3. And then I just have to get y by itself. This is a fairly quick one here. Subtracting 3 gives us h inverse of x equals x minus 3. To find the inverse for f, let me first start by switching x and y. So we've got x equals -y to the 5th plus 2. Next, I need to isolate y. First step to that is subtracting 2 from both sides. And then I think if we multiply or divide by -1, that's another good step. So that'll be -x plus 2 on the left side equals positive y to the 5th. And then finally, we'll take the 5th root of both sides to get rid of the 5th power. So we'll have f inverse equals fifth root of negative x plus 2. On this problem, we're trying to get the inverse of the f function. So to do that, let's begin by replacing x with y and y with x. So I'll write x equals fifth root of y minus 3. And after that, I just need to get y by itself. I need to get rid of that fifth root as the first step in the process. So let me do the fifth power for both sides. I've got x to the fifth equals y minus 3. Now I just have to add 3 to both sides, and I can write f inverse equals x to the fifth plus 3. To figure out the inverse for this function, we're going to start by switching x and y. So I've got x equals cube root of y plus 3 minus 1. Next, we need to get y by itself. So let me start by adding this 1 over here to get rid of that. And now to get rid of the cube root, I need to raise both sides to the third power. So I'm going to have parentheses x plus 1 cubed equals y plus 3. Make sure you have that parentheses over there. Finally, we subtract 3, and we can write f inverse equals x plus 1 quantity cubed minus 3.